There was one thing yesterday that I kind of skipped over because of time, but I want to talk about it right now. It's not that, it doesn't take that long. They call it the fundamental theorem of algebra. It sounds important, doesn't it? Seems like it's the most important theorem that you'll ever do in algebra. I don't know if that's completely true, but that's what they call it anyway. Fundamental theorem, and it's pretty easy. I mean, it's easy to use, I guess. Fundamental theorem of algebra. There's probably a lot more to it, but this is what we're going to use. This is the part that we're going to use. Here's basically what it says. I'm not going to write the whole thing down, but I'll talk about it. It says, every polynomial equation with a degree greater than 0 has at least one root in the set of complex numbers. All right? So, as long as the degree is greater than 0, you're going to have at least one root. So what does that mean? I'll give you an example here. So watch. If I had a little, let's do a little x and y axis here. I'll just try to get this done quick because I only need to do one example today. Let me copy that. Okay. So if you have, what if you had something like y equals, I don't know, 2x plus 3 or something like that, all right? I'm not going to get real specific with this, but that would go right there. Just looking at this equation, or just looking at this graph, how many roots are there? Do you remember how we know what the roots are? Where it touches the x-axis, that's right. How many times does that equation, that line right there, touch the x-axis? Just once, okay? So what is the degree of that polynomial? It's the exponent. What's the exponent? It's a 1. The exponent to the variable, okay? So there's your variable, so it's x to the what? First. We don't always write it, but it's x to the first. Would you agree? So when it's got a degree of 1, that means how many answers am I going to get? How many x's am I going to get? Just 1, because it only crosses the x-axis at one place. You with me on that? All right. It'll make more sense the more we do. So let's do this one. What if I had something that had like x squared, okay? So like y equals x squared, or some variation like that. What's that going to look like? It's going to look like this, isn't it? How many places does this graph hit the x-axis? 2 places. So check this out. Are you seeing a little pattern? Let me think about something here a second. Yeah, we'll just stop right there for this part of it, okay? So if you have like y equals, I'm just making something up, 3x to the 5th, blah, 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 plus blah, 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 okay? So let's say that is the degree. So how many answers, how many x's are we going to have? How many times does it hit the x-axis? 5 times, okay? So we're going to have 5 answers. So with that in mind, watch this. This just kind of helps us know how many answers we're going to have, because sometimes we'll get 1 answer, sometimes we'll get 2, sometimes 3, 4, 5, depending on what we're solving for. So if I gave you this to solve for, if I asked you to solve this right there, 9x to the 4th minus 35x squared minus 4 equals 0. All right, let's take a look at this. We're going to solve this. Looks kind of crazy, but we are going to solve it. And we want to know how many solutions should we have. So what's the degree of this polynomial? 6? Now you take the highest exponent. 4, right. So that tells you the degree of the polynomial. All right. So how many answers are we going to have? we're going to have x equals what? How many answers? 1, 2, 3, and 4. So knowing the degree of the polynomial is going to tell you how many answers you're going to have for x. Stop shutting the door. Just let it rest on it so people can just open it. But then everybody shuts it afterwards. All right. You follow me? So all this thing does that we just talked about, it just tells you how many answers are you going to have for x. So how many answers does this thing have once I solve for x? How many answers? 4. Okay? So that's a good starting place. At least we know once we finish it, did I come close to getting it right or not? If I come out with 4 answers, it's probably good, it's a good indication maybe that we got it right. So how in the world are we going to solve something like this? I probably need to, I should have written something down. We haven't learned how to factor something like that yet in here, have we? But they're making big assumptions in this book that you already know how to factor something like this. But in my Algebra 2 class, we actually are factoring stuff like this. So let me do an easy one for you. Tell you what, let's put this on hold for right now because I need to go back and teach you some Algebra 2. All right? I think you're going to need it. Is that all right? All right. So let's do a little bit. So if I asked you to factor something, because some of you struggled with we had a factoring problem we had to do the other day, and it was really easy, and then people were really struggling. Oh, I don't know what that means. So I might have to teach you a whole entire lesson just on factoring before we actually do this one. All right? Because this is a little bit complicated, especially if you don't know how to factor. Let's go way back in time and do a real easy factoring problem. So what if I had something like this? What if I had 3x squared, and I'm taking this right from my Algebra 2 book, all right, because that's what we've been doing the last few days. What if I asked you to factor this? What does that mean, factor it? Well, here's something. Watch this. This next thing I'm just making up off the top of my head, okay? So what if I had 2x times 3x squared minus 5y, okay? What if I did this, all right? Could you multiply those together? I hope you could. If not, you're in the wrong place. But watch, if I was going to multiply that together, I would just do distributive property, agreed? So what would this be if I multiply this times this? I need answers. I need you talking to me so I know that you're paying attention. 6x cubed, very good. All right, and then I'm going to take that 2x and multiply it by this. There's a minus, so we put a minus. What's that going to be? 10xy, very good. Okay, so that was just regular multiplication. That was not factoring. Factoring is this. Factoring is starting off, whoops, daggone it. Grab it. There we go. Factoring is starting off with this and ending up with that. Because what does it mean to have factors? Like, for instance, if I had 3 times 2 equals 6, what is the 6? 6 is the, give me a word. It's the answer to a multiplication problem. What's the word? It's a product. Sum is addition. Okay, this is product. Okay, what are the two things that are being multiplied to get the product? What do we call those things? Somebody get the door, please. What are these two things called? Nobody? These are called the factors. Okay, these two things that are being multiplied are called the factors. The answer is the what? Is the product. Everybody got it? You guys paying attention? I don't think I got 100%. Everybody ready? Look, I know it's Friday. I know it's last period. I know they had you in the gym and all that stuff. I'm determined to teach this to you, all right? So I need you to watch and pay attention. So look, these are called the factors. So these two right here are the factors. These are the two things that are being multiplied to get my answer. You see it? What are the factors of 6? 3 and 2. And you could also have 1 and 6 too, couldn't you? All right. So those would be your factors of 6. But what are your factors of this? Well, you got to figure out what times what equals this thing right here. So here's what we do. We factor out what we call the greatest common factor. You remember that, don't you? What's in common? Let's just take a look at the 6 and 10. What's the greatest number, the largest number that's in common with 6 and 10? 2 is, right. So you factor out a 2. That's what we're doing. When I say factor it out, what are we really doing? We're going, well, actually, that was something. It's on the next step. So you factor out a 2. That's what's in common. What about the x's? I got an x cubed here and an x to the first here. How many are in common with both of them? To the what? Just the x, right. There's only an x in both of them. And you're like, Mr. Hammer, there's an x cubed here. But there's not an x cubed here, though, is there? All right, there's an x here and there's an x here. That's what's in common, so I factor out an x. Now, this is what I was going to talk about earlier. I factor it out to 2x. I want to find out what's left over. Okay, this is kind of like the opposite. What did we do to get this in the first place? We multiplied, didn't we? How do I go the opposite way? I'm going to do what? I'm going to divide, right. So what I'm going to do is take that 6x cubed and divide it by the 2x. And I know it will divide because I picked a number that is a common factor with both of them. All right, so 6 divided by 2 is 3. X cubed divided by x is x squared minus 10 divided by 2 is 5. Look, x divided by x, what happens to that? Cancels out, and I'm left with a y. Isn't that what I started with to begin this problem? Is that this is a lot easier? Okay. But do you understand what a factoring is? What I'm doing when I factor? So let's go to this. All right? It's the same kind of deal. All right? So what's in common? Now, this is just, there's all kinds of ways to factor. This is a greatest common factor. All right? That's what you should always look for first. Not everything has a greatest common factor. All right? But this one does. So what's in common with both of these terms right here? A 3. And a what? No. And an x. Okay? X is in common with both of them. 3 is in common with both of them. I put a parentheses, and now I factor it out. So what do I do? When I factor it out, and I'll say that a lot, okay? Some teachers don't like that term, but I'm okay with it. When I say factor it out, you're dividing it out, aren't you? All right, so 3 divided by 3 is 1, x squared divided by x is x, put the sign, minus 15 divided by 3 is 5, that x cancels, and that's what I'm left with. So that is now factored. These are the two things that are being multiplied together to get this. That's what I'm doing when I'm factoring something. Does that make sense? Okay. Now, there are other type of factoring problems. Let me flip in my Algebra 2 book back a little bit. So I'm giving you like a real quick, let's see. What do you call that? I don't know, just a quick lesson on factoring. There's some word I was thinking of. I can't think of anything anymore. What if I had something like this? I'll tell you what, I'm going to go backwards. What if I had this? I'm going to make this up, just off the top of my head. So x plus 3 times x, I don't know, minus 7. Okay? What if I asked you to multiply? That's already factored, right? There's two factors. There's two things that are being multiplied together. What if I asked you to multiply that? What would you do? Remember FOIL method? Remember that, don't you? Okay, or distributive property. So what do you get? X times x is x squared. Then x times negative 7 is negative 7x. Then the inside, remember outside, inside last? Remember that? Okay, this is plus 3x. And this is minus 21. Let's simplify it. What is that? X squared what? Minus 4x. Whoops. Minus 21. Yes? So what we're going to do, this is what I'm trying to teach you today. What I'm trying to show you, and let's do this. Let's bring this. Come on. Grab on. There we go. What I'm trying to do is to go from here to here. So this is what I'm going to give you, and I want you to be able to come up with the factors of that polynomial. We call this a trinomial, right? We talked about that yesterday. This is a trinomial. There's 3 terms. This is called trinomial factoring. When you have a quadratic is ax squared plus bx plus c. That's called a quadratic. Everybody see that? This is an easier quadratic because the a is a 1. It gets a little bit more difficult. We're going to do that next when the number out in front is not a 1. When it's a 1, it's kind of easy to see. Do you see any relationships between these two numbers right here and this number right there? Look at it. I got a positive 3 and a negative 7. How did I get a negative 21 out of it? I multiplied them together, didn't I? Just multiplied them. Would you agree? Everybody see it? Nod. Okay, I'm not getting much feedback from you guys. It's hard to tell if you're getting this or not. So watch. 3 and negative 7, if I multiply them together, it's negative 21. Is there a relationship between those two numbers and negative 4?
7 minus 3.
Well, it's positive 3 and it's a negative 7. So if I add those together, I get negative 4, don't I? So what we're trying to do, so I kind of pulled the curtain so you could see what's happening behind the scenes. But now what I want to do, actually let's get rid of all of this. What I want to do is I want to take this. I'm going to give you something that looks like this, and I want you to tell me the two factors of this. All right? It's kind of like backwards distributive property or backwards FOIL method. I don't know if any teacher said that to you or not. A lot of teachers would say that. All right? So it's kind of like backwards FOIL method. So that means this times this has to equal what? X squared. So what times what is x squared? X what? X times x. Agreed? All right. Now, these two numbers, this is what I was getting at. This number here and this number here have to multiply to become what? Negative 21. And those same two numbers have to add up to be what? Negative 4. So you got to think in your head. This is where it takes a little bit of thinking. You got to know your multiplication tables. Okay, if you know your multiplication tables, it's not that hard. What times what is 21? Well, if you went through them, there's not that many options. You got 1 times 21. Is there any way I could take a 1 and a 21 and get a negative 4 out of it when I add them together? There's no way. What's my only other option? 3 times 7. Is there a way to get a 7 and a 3 to become a negative 4? Yeah, as long as what? The 7 was... It doesn't really matter which one's first. Actually, let's do this. This is one thing that I like to do. I like to put plus and minus. Why did I put plus or minus? And minus because when they multiply, it multiplies to be negative, right? Anything that multiplies to be negative, one has to be positive, one has to be negative. So I know one's going to be positive, one's going to be negative. Agreed? All right. And they also have to add up to be negative 4. So I got 7 and 3. Those are the numbers I'm using. Where do I put the 7? Do I put the 7 with the positive? No, because when I add them up, it has to add up to be what? A negative. So where's my 7 going to go? With the negative. And where's the 3 going to go? With the positive. Now, does that work? Does 3 and negative 7 equal negative 21? Yeah. Does positive 3 minus 7 equal negative 4? Yep, it works. Is that what I originally gave you to get this in the first place? It is, isn't it? Okay, it might be a different order. I don't know. I can't even remember. I erased it, but yeah, that's how you factor. That's trinomial factoring. Do you have any recollection of doing this last year? A little bit. So you did do it then. Yes? I'm not saying that you remember it and you got it down like that, but do you remember actually doing it? That's okay. I'm teaching it to you now, okay? So we're going back to Algebra 2. Let's do another problem. Here's another one. X squared minus 11x plus 24. Okay, so here we go. I want you to factor it. That's what this thing says. They all say factor. So what's the first thing we do? Well, before I even put in anything, I got to have what? Some parentheses. So I put the 2 parentheses, okay? I always look at the signs first. That's the first thing I do, all right? So this times this has to equal positive, but this plus this has to equal negative. So what are my signs going to be? Is it? One positive, one negative? Because if I multiply them together, I can't get a positive. They got to both be what? Negative. Because two negatives multiply to become a positive, correct? And then the two negatives add up to become a negative. All right, so that's the first thing that I like to do. Not everybody does. I like to do it that way. Now, what times what is x squared? X and x. Now, this is where the thinking comes in. You got to think, what times what is 24? And you could get a negative 11 out of it if you add them. 8 times 3, right. 24 times 1, there's no way you're going to get a negative 11, right? 2 times 12, that's a little closer, but is there any way to get an 11 out of a 2 and a 12? No. And what's the only other option? 3 times 8, 8 times 3. So which one, well, and actually, it doesn't matter what order, does it? Because they're both the same signs. All right, so it doesn't matter if it goes x minus 3, then x minus 8, doesn't make any difference. So there you go. You just did another factoring problem. See how easy that is? You can do one more like that?
Yeah, let's do
Good idea. Let's do that. This is where it gets a little bit, and I got a method to show you. Got a way to show you. So let's do one like this. Let's go 12x squared plus 5x minus 2. Now this one's a little more difficult. Why is this one a little bit more difficult? Because that 12, that coefficient in front of the x squared, exactly. Okay, so that 12 right there makes it a little bit more difficult. So here's a little trick. You could do this. Sometimes it works great. Sometimes it takes forever. Just depends on how lucky you are just guessing. There's a guess and check method. All right? So you could do this. You could say, well, let's do the signs first. They multiply to be negative. So automatically that means what? One's positive and one's negative. Okay? Now, to get 2, like the last one right here, what times what is going to give you 2? 2 times 1, right? Or I could have gone what? 1 times 2. Agreed? All right, that's the only options. Now 12, I got a bunch of options. I got what? 1 times 12. I got 2 times 6. I got 3 times 4, right? And then since I got a plus and a negative, I could have a positive 1 and a negative 12. I could have a negative 12 and a positive 1. Or did I just said the same thing, didn't I? You could have a positive 12. I don't know what I just said. Let's say it again. I could have a positive 1 and a negative 12, or I could have a negative 1 and a positive 12. Did I say it right? Okay. All right. And then you could do the same thing with 2 and 6, right? One's negative, one's positive. You could switch them. Same thing with 3 and 4. Do you see the amount of options that you have? There's a lot of options. Sometimes you might get lucky and guess the right option. I don't know. Let's just guess one. What times what do you think would be a good one to use to get a positive 12? Three times 4? Okay. Now watch this. Would you agree that 3x times 4x is 12x squared? Yes. Do you agree that positive 2 times negative 1 is negative 2? Yeah. How do I know if that's factored correctly? I got to do the outside and inside, right? So what's the outside going to give me? Negative 3x. What's the inside going to give me? What? Positive 8x. Okay. So negative 3 plus 8 is what? It's positive 5. Do I need to write it down? I think I do. Negative 3x plus 8x. What is that? Check it out. You actually just factored it in one shot, one guess, all right? And I was just going by what you guys were saying, right? Or what Cam was saying anyway. So she got it in one shot. But the problem is that doesn't always happen, all right? You might try a bunch of different numbers. So for instance, what if you would have tried the 1 here and the 2 here? Would that still give you the same thing? Well, your first term is still going to be 12x squared. Your last term is still going to be negative 2. But what happens to the outside and inside? What's the outside? Negative 6x. What's the inside? Plus 4x. What's that give you? Negative 2x. Is that a negative 2x? It's not. So what do? You try again. And then you try again. And then you try again until you get the one that works. That doesn't seem like a great idea, does it, to do that? So let me show you a better way. All right. Now, the way we did it, it actually worked, and it worked first chance. That was nice. Doesn't always do that, all right? Now, this method I'm going to show you is a little bit lengthy, but it works every time, all right? So this is what I ended up doing. So what I'm going to do is take that first coefficient and that last number, multiply them together. So I'll even show you. I'll show you every little step. So 12 times negative 2 is negative 24. You with me? Okay. So now what I want to do is I want to take that negative 24 and I want to find out what times what is negative 24, and those same two numbers added together equals that middle one, which is a positive 5. You with me? So let's, in our head, so I multiplied the first and the last ones together to get that negative 24. So I want to find out, and I'll show you why this works, okay? As we move on with this problem, I'll show you why it works. So this times this has to equal negative 24, and those same two numbers that I picked have to add up to be positive 5. Very similar to what we did here. Would you agree? These two multiplied together had to be negative 21. These two added up had to be what? Negative 4. Same thing right there. So it's very, very similar to what we've done before. So think of some numbers. What times what is negative 24? And those same two numbers come out to be a positive 5. 8 and 3, right. So positive 8 and what? Negative 3. All right. Positive 8 and negative 3. You with me? Do you agree that that works? I did. Thank you. All right. Negative 3. Everybody good? Now, why in the world did we figure that out? I'm glad you asked, because what we're going to do is this. We're going to manipulate this equation just a little bit. We're going to take that positive 5x, okay, and we're going to change it a little bit. It's still going to equal 5x, but you'll see. Watch. What I'm going to do is just write 12x squared. Let's see which one I want to do. Let's do this. I'll show you why in a second. I get 8 here and a 3 here. I could have also said negative 3 plus positive 8, couldn't I? There's a reason I'm going to do that, and I'll show you after I do it. I'm going to go back and show you why I picked this order right here, okay? So what I'm going to do is rewrite this, okay, as negative 3x plus 8x. See what I just did? I took that 5x, and I just rewrote it. I wrote it as negative 3x plus 8x. Would you agree that that's still the same as this? So can I put an equal sign here? Yeah, absolutely. Now, why in the world would I do that? I'm glad you asked. Here's what I'm going to do. This is another type of factoring. Again, this is stuff like, it's supposed to technically be like an Algebra 1 topic, all right? But usually, you really get into it in Algebra 2, okay? Like high-level Algebra 1 classes would cover this, but normally it would kind of fall on the Algebra 2 teacher to teach you this. But I'm teaching it to you now. So watch. It's called factor by grouping. So what I'm going to do is take this. Now, the stuff that I'm doing on this problem right here is the stuff that I want to do on that example that I still have to do, okay? So I'm going backwards to show you some basic stuff, and then I'm going to apply this that we're doing right now. I'm going to apply that to that example 4. All right, so here we go. Look at this. What I did is I grouped them together. And the reason that I put the 3 with this and the 2 with this is because if I would have put a 8 here, or let's see. Yeah, if I would have made this the 3x, is there anything in common with 3x and 2? There's not. Well, let me just show you. So what I did is I grouped them. So just look in that first parentheses right here. Is there anything in common? Is there a greatest common factor with both of those? No, not a 4. It's not a 4. There's no 4 here. I know what you're thinking, but a 3. There's a 3 in common, right? I got a 12 and a 3. What's in common with 3 and 12? There's a 3. What about the x and the x squared? There's an x. So there's a 3x in common with both of these, correct? So what I'm going to do is I'm going to factor out a 3x from this. What am I left with then? So I put a parentheses. What am I left with if I divide this by 3x? 4x minus, what's that? It's not a 0, it's division. It is a 1. 3x divided by 3x is a 1. See what I just did? I just did a little GCF, greatest common factor, in that part right there. Now I'm going to do the same thing in this parentheses right here. Is there something in common with both of these? A 2. Right, so I'm going to put a plus because of that sign right there. I'm going to factor out a 2, and I'm going to figure out what's left over. So 8x divided by 2 is what? 4x. Minus 2 divided by 2 is 1. Now check this out. I got a 4x minus 1 here and a 4x minus 1 here. If you do this correctly, that's what's going to happen. All right? You're going to have a common factor with both of these. This stuff still equals this, and this equaled that. So this right here, if I multiplied all that out, it would still equal this thing right here. Okay? So they're still all equal to each other. But check this out. We're almost done. We almost have this thing factored. And you're like, why would you go through this pain? Why wouldn't you just guess? Just guess a bunch of times. You could do that, but I'm telling you, I like this way so much better. Because we did guess it right off the bat. It's not always going to be that easy. So watch what happens. What's in common with this whole thing and this whole thing? What's in common with both of those? A 4x what? Minus 1. That's right. So what I'm going to do is I'm going to factor out that greatest common factor, that 4x minus 1. So if I factor it out of this, I'm going to take this divided by 4x minus 1. What am I left with? A 3x. Okay? Plus, what if I factor out a 4x minus 1 from that? I'm left with a 2. And that is now factored. It's the same thing as we got when we guessed. Would you agree? Let's just make sure it works. 4x times 3x is 12x squared. The last one, negative 1 times positive 2 is negative 2. Do the outside. The outside is 8x. The inside is negative 3x. That's what? 5x. Does it work? Does this equal this? It absolutely does. Okay? I know that's probably the first time you ever saw that. Is it? Yeah. So it'd be nice if I could give you a whole bunch of problems that are like this, but we got to move on to the example that they gave us. And again, they're kind of assuming that you already know how to do this. All right? So that's why I went back a little bit. So let's just rewrite that problem again. I'm recording this, so if you want to go over it again, right, write it out, try it yourself, right? If you get stuck, watch what I do in the next step, pause it, see if you remember what to do in the next step, all right? That's the best way to do this. That's why the YouTube videos are so good, is because, not because of me, but because you can stop it and try it, right? Go back and all that. So what did we have to do? We want to factor, actually, well, let me show you something else. Oh, all right, let me show you another thing. What if I said all this was equal to 0, and I asked you to solve for x? You probably remember this, don't you? So let me show you a really important thing in algebra to do this. What if I said AB, did I do this? I did this already, didn't I, the other day? Let's do it again. What if AB is equal to 0? Tell me something about A and tell me something about B. Either one of them could be 0, right? If A is equal to 0, would you agree that 0 times B is 0? I don't even care what B is. If A was 0, doesn't matter what B is, this thing's going to equal 0. Agreed? So what we're going to do, like for this, what if I had 4x minus 1, and what if I had that set equal to 0? This times this equals 0. So that means what? The 4x minus 1 could equal 0. And what else? The 3x plus 2 could equal 0. You see that? And now you just do your math and you solve for x. Add a 1 to both sides, divide by 4. You can do that in your head, can't you? So x would be 1/4. Subtract a 2, divide by 3. So x is negative 2/3. So if this was set equal to 0, and they just said solve for x, or find the roots, or find the zeros, remember that? It means the same exact thing, then this is what you would do. All right, you would factor it, you'd set the factors equal to 0, you'd solve, and then you got answers for x. So that's what x would be. I could put 1/4 in for x, all this stuff would equal 0. I could put a negative 2/3 in for x, and this whole left side would equal 0. All right? All right, got 10 minutes. Do you think we can get this? So let's write that. Let's finally go back to that example 4 that we started with, and then I realized that I didn't think you had enough background. Now I know that was very quick. Let's see. Minus 35x squared minus 4 equals 0. So here's what they're asking to do. They're asking to solve for that. Now remember, we know how many answers we're going to have. That's easy. How many answers am I going to have? Talked about that earlier. 4 answers, right? Because the degree of the highest one is 4. So you're going to have 4 answers. Let's see how in the world can we get 4 answers. So this is one of those ones with, now this has got an x to the 4th and an x squared, which makes things even a little bit weirder. I'm just going to do it and just watch and write it down. Is that all right? And then maybe we'll go back and revisit it a little bit, because this is a pretty big step up from what we just finished doing. Not a big step, but a little bit of a step. So what we're going to do is take that 9 and that negative 4. Again, you could just guess and check if you wanted to, but this is what I'm going to do. I'm going to go a little bit faster because time's running out. So I'm going to go 9 times negative 4 is negative 36. Remember what we did? Now I got to find 2 numbers that multiply to be negative 36. And those same exact 2 numbers, what are we going to do with those? Add them up. And what are they going to have to equal? Negative 35, the middle number, okay? So it has to add up to negative 35. That's pretty easy. All right, so what numbers multiply to be negative 36 and add up to be negative 35? 36 and 1, right? 36 and 1, all right? But it's not just 36, it's what? It's negative 36, okay? So it's negative 36 and positive 1. This is negative 36 and positive 1. Does it work? Yeah. These multiply to be negative 36. These add up to be negative 35. So what I'm going to do is I'm going to rewrite this, but instead of writing negative 35x squared, I'm going to write it with these other factors. So watch. 9x to the 4th minus 36x squared. I need a squared there because this is 35x squared. You see that? And this is going to be what? Plus 1x squared minus 4 equals 0. All I did was rewrite this negative 35 as negative 36x squared plus 1x squared. That's all I did. Okay? How did I know to use those numbers? I did this stuff over here. Now what am I going to do? I'm going to group them together. I'm going to group them like this. So how do I factor this? What's in common with everything here? I got a 9 and a 36. What's in common with both of those? 9 is, right? Yep, so there's a 9 in common. What else? I got an x to the 4th and an x squared. X squared's in common. I'm going to factor it out of this. What am I left with? 9 divided by 9 is 1. X to the 4th divided by x squared is x squared. Minus 36 divided by 9 is 4. X squared divided by x squared is it's just 1, right? So that's what I get there. Plus, what about this? Well, there's nothing in common with those. So I just write x squared minus 4 equals 0. Agreed? Now, take a look at these two. Is there a greatest common factor? X squared minus 4. Good. So I'm going to go x squared minus 4. Factor it out. What am I left with? If I take the x squared minus 4 out of this, what am I left with? 9x squared. What if I take, when I say take it out, I'm dividing. Okay, so what if I divide this by x squared minus 4? What am I left with? A 1. Okay? and that equals 0. Here's another factoring that we didn't talk about. It's called a difference of two squares. Time's running out, so I'm just going to have to show you. Do you remember learning difference of two squares? No. Okay. Did you learn anything last year? All right, so difference of two squares. I got 5 minutes. Let me show you real quick. What if I had like x plus 3 times x minus 3? Look what we get. Watch. Let's FOIL. X times x, x squared. Outside, negative 3x. Inside, positive 3x. Last, negative 9. So what do I get? X squared minus 9. Agreed? I could do that again. Let's do another one. X plus 5 times x minus 5. Let's do this a little more in our head. First is x squared. What's the outside? Negative 5x. What's the inside? Positive 5x. What happens to those? They cancel. And then the last is negative 25. Do you see something? Look at this. Look at this. And look at this right here. If I have, this is called a difference of two squares. Difference meaning minus. Is there something being squared to give you x squared? Yeah, x is. What's being squared to give you 9? A 3. What's being squared to give you x squared here? X. What's being squared to give you 25? A 5. Let's go to this. What's being squared? Is this a difference of two squares? Yeah. So here's how we factor it. We put two parentheses. Notice, you got 1 plus, 1 minus. So that's what I'm going to do here. 1 plus, 1 minus. What do you got first? You got an x. What do I got next? In this case, it's a what? It's not a 4 because this times this has to equal 4. So it's going to be a 2. So that is now factored. And then you can't factor this right here. And that equals 0. Almost done. Well, getting close. Forgot the x, didn't I? Okay, let's keep going. All three of these things equal 0, don't they? So watch what I'm going to do. I'm going to go x plus 2 equals 0. I'm going to go x minus 2 equals 0. And then I'm going to go 9x squared plus 1 equals 0. These first two are the easy ones. What's x equal here? Negative 2. So that's one of my answers. How many answers am I going to get? 4. Remember at the beginning? It was to the 4th power? Okay. So add a 2. What's x here? 2. So those two of my answers. Now, I got to solve for x here. This is a little weirder. But it's pretty much straight up algebra. Subtract a 1 from both sides. So I get 9x squared equals what? Negative 1. Divide both sides by 9. That's easy, right? It's algebra 1 stuff right there. So now what do I have? I got x squared equals negative 1 over 9. Square root. But now, this is what we talked yesterday about imaginary numbers, right? This is where it's going to come in. If I take the square root, and it's not just a square root. Do you remember this? Put a plus or minus in front of it, right? So what happens here? That cancels with that. So I got x equals, and I got plus or minus. And what do I have here? I got square root of negative 1 over the square root of 9. Plus or minus. What's the square root of negative 1? I over the square root of 9, which is 3. Or a better way to write this is like this. Plus or minus 1/3 I. But I thought we were getting 2 answers. Or, yeah, 4 answers altogether. This is x, but look what we got. We got what? We got a positive 1/3 I, and we got a what? A negative 1/3 I. Check it out. We got 4 answers just like we thought we would. All right? And that's what it is, okay? If we had time, we would graph a little bit, but there you go. I shoved in a whole bunch of stuff from the past that you should have known, but if you didn't, now you do. All right? What I would suggest is you go back and you watch a Khan Academy or you watch something like that. Maybe go back and watch my Algebra 2 videos from the last 3 days. All right? And it talks about factoring and that kind of thing. All right?